Good morning, good afternoon, good evening, ladies and gentlemen, and welcome to the next video. In this video, we'll be learning how to solve for x in an exponential equation when our bases are the same. Now, this is designed specifically for grade 9s, mainly so that we are not using logarithms to solve for this because they don't know logarithms yet. Okay, so let's look at an example. So let's say you have 3 to the power of x is equal to 9. Now I'm going to break down the steps you would normally do in this case. And step 1 you would do here is ask yourself, is there any way, I'm going to underline any way I can make both numbers the same base? And that's the first step we do here. So the first step is there any way I can make them both the same base? Now, the best way to do this is to break it down to its prime numbers. And when I look at both sides, I have 3 on this side and 9 on this side. Now, in case you guys forgot, the word prime number refers to a number that can only be divided by 1 and itself. Sorry for noise in the background, guys. I am doing this video out of school. So, what do I mean by prime numbers? Well, obviously the number 3, there's no other factors for 3 except for 1 and 3. For the number 4, well, there's 1, 2, and 4. Because I can do 2 times 2 and give me 4, but that number is not the 1 or the 4, which means 4 is not a prime number. What about 5? Well, 5 can only be divided by 1 and 5, so 5 is definitely a prime number. So with that in mind, let's look back at our example here. In our example, we have 3 to the power of x is equal to 9. So 3 is already a prime number. So I don't need to touch it. I can leave it as 3 to the power of x is equal to. Well, the number 9 is definitely not a prime number. I can definitely make it smaller. I could definitely turn it into its prime number by remembering that 9 is the same thing as saying 3 times 3, which, if I recall correctly, should mean that this is 3 to the power of 2. This brings us to our second step. The second we have the same base. Do we have the same base right now? Absolutely. We have a 3 here, we have a 3 here. So the second step would be, once we have the same, I'm going to underline same because same is a very important word, the same base, we forget about it. Okay, so we forget about the base. In which case, so they are both now the same, so we forget the bases are here. And essentially, we will make our exponents equal each other. Okay, so we have x, and we want to make it equal to 2. Now, is the x by itself? Yes. So x is clearly 2. So when we look back at our example, we have the example of 3 to the power of x is equal to 9. Essentially, what they're asking you to do is they're asking you, what x could I put, what number could I put there to give me 9? And the only answer there would have to be 2, because 3 to the power of 2 is 3 times 3, which is 9. So this satisfies our equation. Okay, so let's look at another example here. So looking at this next example, now this is a next level example. This is a lot harder than the last example because in the last example, we had one of our sides already as a prime number. So in this example, people are saying, oh my God, Mr. Eltahami, what are you doing to us? Why are you giving us two numbers that are not the same? Again, don't panic. First tip is obviously for these questions, never panic, because you just need to look at both of these numbers. So let's put them here to the side. Let's say I put 27 here and I'll put 9 here. Now 27, you want to break it down. Now I know that 27 is another way of saying 9 times 3. 3 is already a prime number, so I don't need to worry about that. But I can further break it down to 9, because 9 is 3 times 3. Are they all primes now? Yes, I have a 3, a 3, a 3. These are all primes. How many 3s do I have? I have 3 3s, which means this is 3 to the power of 3. So 27 is 3 to the power of 3. Let's do the same thing for the 9. Well, we did that last page, so we know it's already 3 times 3, which we know should already be 3 squared. So let's put this in here. So when you put this in here, remember our first step would be to change it into a prime number, so we're doing that right now. So 27 should be changed into 3 to the power of 3 is equal to, 9 should be changed into 3 to the power of 2. Put my bracket there. Now, there is a reason I put the bracket. And the reason you put the bracket is because, remember, 27, this is 27 here. We're not changing anything here. 3 to the power of 3 is 27. But it doesn't mean the x disappears. The x is still there, and it has to apply to this bracket. So that 27 becomes 3 to the power of 3. But now we have to add a second step here, and the second step is we have to get rid of this bracket somehow. And we learned in our exponent rules, when I have an exponent on the outside of the bracket and an exponent on the inside, we should multiply these exponents, turning it into 3 to the power of 3x is equal to 3 to the power of 2. Now, are these the same base? They most certainly are, which means I can now go to my last step, which is to forget the bases are there. Once again, the bases are still there, but we're just forgetting they're there for now. We're kind of ignoring them. And we're making our exponents equal. Now this just turns into a solve for x question. And to do that, you need to get rid of the thing that is bothering x. So right now, the thing that's bothering x is this 3. What's the 3 doing? It's multiplying the x. Why do I know it's multiplying? Because there is no sign in between the 3 and the x. So it's kind of like, that best friend that just doesn't want to let go. How do you get rid of them? Well, you have to divide them. But you can't just divide one set of friends. You have to divide both sides of friends. What this ends up doing is, once again, you have the same friend wearing the same shirt, same friend wearing the same shirt. They want to run away from school. And you have left over x is equal to 2 over 3. And that's how you solve this type of question. The last type of example we're going to look at is an example where now you have a fraction. So in this example here, once again, you still want to do the first step. And the first step is to try to make both numbers the same. But when you have a fraction involved, which we do here, the first thing you want to do is get rid of the fraction. And the only way to get rid of the fraction here is to move the 9 to the top. So that's the first thing you want to do. You want to move the 9 to the top first. So you do this, you have 9. But since I moved it to the top, remember, if I don't see an exponent here, it's the same thing like saying there's a 1. That becomes 9 to the power of -1, because we took the reciprocal, which means we change the exponent, is equal to, yes, that's a bad, horrible equal sign there, I apologize, 3 to the power of x Now that the 9 is up, we follow our steps, and we know that 9 is 3 times 3, which I know is 3 squared. Once again, this should be in brackets with the negative 1 on the outside. Which then, of course, we have an exponent on the inside, exponent on the outside. Bingo bango, that should be 3 to the negative 2 is equal to 3 to the x. Are my bases the same? They absolutely are, which means I can say x is equal to negative 2. Now, you could have also done this a second way. And the second way you could have done this, let's assume we left this as the fraction. This way might be a little bit of an easier way for some people to view it. The first thing you could do is right away realize that this 9 is 3 times 3, which would end up giving you 1 over 3 squared. That doesn't change your next step. You still have to move the 3 squared up there because 1 over 3 is not the same base as 3. So we move it up there, and the 3 comes up here, and it becomes 3 to the power of negative 2, just like magic, is equal to 3x. And then finally, bases are the same, so we can say x is equal to negative 2. And that is how you solve for your exponent when you have the same base. I hope this has helped everybody, and please let me know if you have any more questions.